Towel again. We have a battery operator, we can move into like singing. We can karaoke the night away if all else fails. What? All right, I'm just gonna get started.
Okay, so real quick though. It looks very fun.
Slides on here. Okay, so we're gonna change. All right, can everybody please take a seat? Man, I could have yelled for like an hour without saying. No, that's what the slide.
It's not, so it's Aaron, it's not, for some reason, it's not sharing. If I go to share.
I was just on the webinar, so we on the video.
No, we're on the, it's on. No, wait, no, it's working, it's working.
We're just saying like glitches, we become regional power outages and stuff like that. Something on here running and then we're doing. Alright, here we are. All right, so I'm Erin Blue. I am a North Idaho program manager for John Limited, and we're gonna have a little talk today here about fisheries on the Priest River and the Priest Basin in general. And we have a webinar going. Last time there was some sound issues, so we have the speaker system so that people can hear us on the webinar. And, I don't know if it's necessary to ask you to use it if you're speaking and if you have questions. We're also going to the owl is not functioning correctly, so on the webinar right now are not able to see me or the speakers or the audience, but they're able to see the slides and they should be able to hear. So that gets at the most important stuff, right? And so we're gonna have 3 speakers today, and then we're gonna slide into questions and answers. All those speakers will be able to help answer those questions. I would like those questions to stick to the information what we're talking about today with fisheries and not veer off into other topics, Priest River related or anything. And we won't most likely get to all the questions, especially on the webinar. So people can write in questions, but they we may not get to them. We weren't able to in the last meeting. So I think we'll just hop into it, make sure we have time for stuff and then we can wrap it up at the end. So our first speaker is going to be Rob Ryan with Fish and Game. And, I'll let him take it from here.
Okay.
You want to use the black one?
I try it without. Can you hear me? Yeah, you good? Okay, I'm gonna try it without.
Because we hear from people online.
Molly said I could try it first.
I'm just saying.
You
like,
can.
That's why we want to.
Um,
Alright, so yeah, I'm a regional fishery biologist with the Iowa Department of Fish and Game. So generically, what I do is keep track of fish populations in the region and then use that information to make recommendations that hopefully conserve native fish or make fishing better in this area of the state. So in this particular region, we split it up a little bit. I do a portion of it. The northern portion of the region is where I focus, and the Priest River and Priest Lake area is a big portion of that area that I spend time in. So with that, I'm going to talk about the fish community of the Priest River Basin. I'm going to start and end, I guess, at a very basic level. I'm going to talk about the types of fish that you find in the basin, a little bit about where you find them, why they're found in different locations. I'll talk a little bit about some of the work that we're doing to keep track of.
Might just need a second. I don't know.
Check. Okay.
That is as low.
Okay.
You have to adjust your voice.
Where was I? I am going to talk about where you find fish, what types of fish are out there. I'm going to talk a little bit about some of the work we've been doing recently to understand more about the fish populations in the Priest River Basin. And then I'll touch just a little bit briefly on sort of some historic perspective on management of the Priest River, specifically in the fishery there, and what has or really hasn't been done there, and some of the reasons why that might be. So to start off,
It was so beautifully working. Here, I can advance it. It is work.
okay, so we'll start with the fish. In the Priest River Basin, there are 3 native game fish. That's it, 3 native game fish. I'll start with some basic definitions. When I use the term native, I'm referring to fish that were present before people started moving fish around. So the geologic time, these fish were there. These aren't something that people brought. They may have been enhanced or otherwise altered since then. These are original fish. And then the term game fish simply reflects or is sort of some terminology that defines the type of fish that anglers are interested in. So these are fish that have been managed over time with the interest of providing fishing opportunity. All of these are salmonids. That's just the family of fish that they belong to. And in general, salmonids are typically cold water fish. So they rely on cold water temperatures to make a living. 3 fish are.
I'm going to do it for you.
Either the batteries.
Can't give it time. This is a senior center.
Yes. Happy agers.
One more back.
Oh,
Okay. Oh, now we're good.
I don't understand.
Anyway, bull trout, top on the list. Bull trout in particular are very sensitive fish to water temperature. So around the region, bull trout are known for their need of very cold water. They're not tolerant to warm water at all. Typically, the range of water temperatures that are most suitable would be somewhere from 60 to 65 degrees and lower. That's where their prime water temperatures lie, where they're growing well and active. Above that, you run into issues with stress. It's not a reflection, though, necessarily of mortality. So all these fish, although they're cold water fish, do have the ability to withstand short periods of warm water to make it go. So even though water temperatures in some of the places that bull trout live or these other fish may live may reach 70 degrees or beyond for short periods of time,
as long as it's not a long extended time, they do well. So, cold trout, cold water fish lives in the most extreme area of cold water that's available in the Priest River Basin. These fish are not widely distributed. In fact, really, there's only one main population that's located in the middle fork of the East River. That's the primary location that cold trout occur. See them scattered occasionally in other locations, but for the most part, middle fork, East River. Cutthroat trout, also very cold water fish, heat intolerant. They are found more widely distributed throughout the basin in places where cold water occurs. These are primarily the tributaries to the Priest River. I didn't mention that. We'll try to specify the middle fork East River, but cold water in the Priest River Basin primarily occurs in tributaries to the main river. So, West-Slope cutthroat trout are widely distributed in those tributaries. In contrast, mountain whitefish are not. So actually, they're found more typically in the Priest River Basin in the river itself, to some degree, the lower ends of some of the larger tributaries, and that's common for mountain whitefish. So mountain whitefish are often found in some of our moderate to large rivers throughout the state. That reflects some of their tolerance to water temperature. So they are more tolerant of slightly warmer water, still considered a cold water fish, but slightly more tolerant.
You just try aiming it here. I just want to do a test. Just toward this. I'm just going to do it for you. You can put that thing down if you want.
Kingfish are not the only fish, of course, in the system, and we have a host of non-game native fishes. So non-game is the term that just reflects these are fish that anglers are typically not interested in. They're widely distributed in the Peace River Basin, but they're most commonly not found in tributaries to the Peace River. They're more common in the Peace River itself and some of the lower reaches of tributaries, or some of the larger tributaries with just that slower, lower gradient water, typically warmer conditions. While these aren't necessarily warm water fish, they're generally referred to as cool water fish in most cases. There are also fish that you find widely distributed throughout the region. So you'll find them not only in the Priest River, but in Ponder River, Monterey, East Lake, etc. Widely distributed for the most part. These include large-scale longnose sucker, northern pike minnow, longnose daisy mouth, red-side shiner, slimy sculpin. So a variety of fish that most people don't think about. Maybe you've seen them, maybe you haven't, but unique fish in their own right. And the one I didn't highlight yet was lake chub, and that's an interesting story in terms of the Priest River Basin, and that's one that's not been classically identified as a fish that is within the Priest River Basin. So they are known to have their native range within the Kootenai River Basin, but more recently in some of the work we've done, and some of the work that the Council Tribe has done, they've been identified in a number of locations around the basin. So kind of a unique situation where perhaps we've identified something that is less known in the past. So in addition to native fish, there are a host of non-native game fish. So these are fish that people brought to the Priest River Basin. These are common fish that actually have been brought to many places throughout Idaho and many places throughout North America in most cases. So rainbow trout are probably the most widely introduced fish across North America, I would wager. And certainly in Idaho, rainbow trout have been stocked in waters throughout the state. In the Priest River Basin specifically, they've been stocked sporadically over time since the early 1900s all the way into the 1990s. Since we have not used those fish, and I will talk a little bit about why that has stopped being the case. Again, another widely introduced fish has been introduced across the western United States. All these fish were intended to provide benefits for anglers and new opportunity and something to catch. Brook trout in particular have some challenges that have come along, some lessons learned with their introduction, and I'll talk a little bit about that as well as the other species once I have described them. But brown trout were also introduced into the Priest River Basin, much shorter time period of their introduction, only a couple introductions. They are present in the basin now, but much less common than either rainbow trout or brook trout. And then smallmouth bass were not intentionally introduced into the basin, but they were introduced in Montana intentionally to provide fishing opportunities. They since worked their way down the North Fork River, expanded in the broader Ponderay system, and have found their way now into the Priest River. So not common, but present. Each of these poses their own unique challenges. Just briefly, rainbow trout have an ability to hybridize with West Slope cutthroat trout. The hybrid really takes away value, I guess, if you're trying to maintain a cutthroat trout population. Potentially you have the end result of losing a pure cutthroat trout population if hybridization becomes too broad an issue. Brook trout, stocked throughout the West, are competitive species that often outcompetes West Slope cutthroat trout, replaces them in streams where you might otherwise want cutthroat trout. In the Priest River Basin, they also pose the challenge of hybridizing with bull trout. So another hybridization issue where you may end up with an end product that has less value than the native fish you're trying to manage for. Brown trout, again, not very prevalent in the Priest River Basin, but do represent potential competitor with native fish. And then finally, smallmouth bass really represent sort of a voracious predator relative to some of the other introduced fish, and there's potential for increasing mortality in those fish you're trying to manage. So within the Priest River Basin, we have a number of life histories that are expressed in the fish that live there. So within the native fish, I'm going to talk or focus primarily on those. We really have two major descriptions of life history. And what I'm talking about when I say life history is really about how fish use the landscape that they have available to them. And it's really influenced in a number of ways by maybe habitat quantity, habitat quality, in some cases by physical barriers that limit the movement of fish. But really the two things I'm talking about are fish that reside in one location throughout their whole life, resident fish, or fish that would migrate at some portion in their life span to a different location. I'll generically call them migratory fish, but there are terms specific to how those fish migrate or from what point to what point they migrate that are referred to in different ways. And when you think about this, really what you might see in a stream, if you walked up to a stream and you caught a fish and said, is that a migratory fish or is that a resident fish? You probably wouldn't know, other than if you knew how old that fish was. So the big difference in large part is a resident fish in the streams that we have around here typically lives its whole life there. It grows very slowly. It might be very small, even though it's very old. In comparison, a migratory fish that left a small tributary and went to like Ponderay, for example, might have a lot more resources, might grow much faster, might result in a much larger fish. So the two pictures I have here on the left is a smaller fish. That's probably a 6-year-old cutthroat trout. It lived its whole life in a stream, and that's probably as big as it will get. It probably will die in the next year or two. And then on the upper right is another cutthroat trout. Same species of fish, could be from the same stream. It swam and went to a larger water body like Lake Ponderay and grew much faster. It will return to that small stream where it came from after it grows to size and spawn and create the next generation. Both have their value, and there's some, a lot of theory about their evolution and the ability of fish to manage through stressful times and splitting your eggs into multiple baskets. And life history traits tend to be lumped into some of those theories. In the Priest River, or in the Priest River Basin, there's some broad, I'll make a lot of broad conjectures because there's a lot going on there and a lot of things that may differ by individual tributaries, but in a broad sense, cutthroat trout, again, reside primarily in the tributaries in those places that are exhibiting cold water. They're relatively abundant in those places, but many of those fish then will migrate out to provide, look for bigger water that will allow them to be successful and continue that population. And I'll highlight a little more detail on that. So bull trout exhibit the same type of life history characteristics that migratory and resident type life history characteristic across their range. In the Panhandle region, we primarily have migratory bull trout, so those fish that don't live their whole life in one location. Generally, they'll spend 1 to 3 years in a small stream where they were born, swim to another location, a larger river or a lake, and then return to spawn when they're 5 to 7 years old. In the Priest River, we've got a well-documented population of bull trout that does just that. They're a migratory population, and they're a relatively unique migratory population in that they actually swim down, when they're a juvenile, they swim down the Priest River, and then they swim upriver. They go up the Ponderay River to Lake Ponderay, where they live for several years and grow and then return. That type of migratory pattern isn't seen in many locations, but it's been well documented here by one of my predecessors in some research that they had done specifically on that population. So again, these fish aren't spending much time in the Priest River, like they're similar to cutthroat trout. It's a migratory corridor to the colder water that exists in the tributaries. So just to give you kind of a little perspective on what bull trout are doing in that one location. Again, this is really the location for Priest River bull trout. Middle Fork, East River, and Uinta Creek is a tributary to that stream. A relatively stable population from a monitoring perspective. Just the figure on the left describes red counts over time, and a red is pictured on the right here. That's the place where a bull trout will dig a nest essentially and put eggs down, and they're fertilized there, and the juvenile fish will hatch in that red. Our primary tool for monitoring bull trout across their range are the use of red counts. It involves physically walking a stream where you know fish spawn and counting individual reds. That count is then used as a measure of a trend in abundance. Doesn't represent all the fish there, but it does represent the portion of spawning that's occurring by adult fish. So on the upper left, we've got a figure with just the trend in red counts, and you'll see a large up and down, and it does appear that abundance has come up, maybe down a little bit, up and down, but that's common for bull trout populations across the range. We see a lot of variability from year to year in red counts. That's common with Ponderay tributaries and the populations that live there, or the populations that occur in tributaries of the Priest River. But in general, I guess we classify it as a relatively stable population. The majority of that spawning is occurring in the Lower East River, so that's highlighted in the bottom left, and then there is some active spawning going on in the community. We have a long history of monitoring bull trout there, among other areas within the region. So West Slope cutthroat trout also exhibit a migratory life history type. In this case, West Slope cutthroat trout actually are very common for them to be both resident and or migratory in the Priest River Basin, as well as populations throughout the Panhandle region. In this case, we have abundant West Slope cutthroat trout in many of the tributaries to the Priest River. Interestingly, though, we've got some recent work that was completed by a graduate student at Eastern Washington University in partnership with the Kalispel Tribe, looking at the genetics of West Slope cutthroat trout across the Ponderay Basin. And in that work, they found some interesting things. We were aware, largely from the Kalispel Tribe's work, that there are migratory fish using the Priest River, but what we weren't certain of or as aware of was that those fish really contribute very much to the more broad Ponderay population. So fish spawning in the Priest River Basin, which tributaries where we know that migratory fish are coming from this genetic evaluation are highlighted with the stars. A number of places they're coming from will do the same type of migratory pattern where they'll come down the Priest River, drop the Ponderay River, and occupy Lake Ponderay for a period of their life. The figure on the right highlights some locations really that were used in a sampling effort to describe the abundance of cutthroat trout and other near-shore fishes in Lake Monterey. These results were actually from a year ago. And fish cutthroat from that project were used in the genetic evaluation and were assigned back to their stream of origin. Where do these fish come from? They're migratory fish. Where is it important that we understand and keep track of their habitat to provide good quality spawning habitat? And all the yellow triangles represent fish that were assigned back to Priest River tributaries. Just highlighting the fact that this is a much broader and connected system with important spawning tributaries that contribute to Lake Monterey and beyond. So, there have been periodic surveys of tributary populations around the Priest River Basin to understand specific questions. There have not been broad survey efforts that have been used to help us understand what's out there. They're time consuming, they're expensive to implement, but they are important. So recently we've been doing some work, not only in the Priest River Basin, but across the region, trying to understand what tributary populations look like. And that helps us in a number of ways. One, we're trying to grasp what species are there, what the mix of species are, what the abundance of those fish are in those species, and then be able to use that information to help think about management questions like where might we be focused on conserving important fish habitat? Where might we look to improve fish habitat? Where might we look to address issues that might influence native fish in a negative way? For example, where might brook trout be very abundant? Where might we think about managing brook trout for the benefit of West Slope cutthroat trout, which is a common activity these days, a common thing people are thinking about because of some of the negative effects brook trout have on cutthroat trout. So we have been implementing a survey of tributaries to the Priest River, something we started last year. The figure map on the left, all the points represent locations where we're intending to go sample to collect information and describe these things about fish populations there. We do that with an electrofishing survey, so we're using some electrofishing equipment on the right where we stun the fish and net them up in a specific reach of these streams, and then we use that information to estimate density, how many fish are in that location, as well as observe what types of fish. So it is just something we're working on. I don't have information to really share with you about that specifically. I can broadly say that cutthroat are well distributed in the tributaries that we've been to so far. Brook trout are also pretty well distributed in some of those tributaries. And a lot of it depends on the type of habitat that's available. Many of the lower reaches or those streams that are lower in gradient, maybe wider or slower, have a siltier substrate, are better suited, or brook trout are more able to take advantage of some of those tributary habitats and do well there. In lieu of information specific about those specific streams,
on your previous map, you had white dots and black dots with green.
those were just referencing some work, places we've been already and places we're going to be. So work we've got done, work we're not. I just wanted to provide sort of an example of the type of information you might expect. So we've already deployed an inventory, a similar type of effort on tributaries to Priest Lake and Upper Priest Lake. And this is the type of information that we'll gain from that work. And I think the same type of concept that we'll see in the Priest River Basin on the Lower River. In general, on the figure on the left, we've got the type of fish that we found in each stream described by color and the proportion described by the amount within the circle. So all the gray circles represent cutthroat trout and cutthroat alone. Where there's black or black mixed in, that color represents brook trout. And then there's some green for bull trout and red for rainbows. But we didn't capture some of the primary bull trout spawning habitat in this particular work, so please don't take away that that's lack of bull trout. But in general, the point being that I think we'll find cutthroat are widely distributed in these cold, complex, good quality habitats that we find in tributaries to the Priest River. We'll also find that some areas are dominated by brook trout or are in part a mix of both species. On the right, is the other portion of that information. We'll gain associated information about density, how many fish are within each zone, and that'll help us think about again, what the quality of the habitat might be. And I'm going to highlight this. We've got Cowsville Creek is right here in the lower left-hand corner. There's 3 small dots there representing very low densities of fish throughout that drainage. That one in particular, when we sampled it, was the quality of the habitat was poor. That would be a great place to think about improving habitat for fish. So it's a great way to describe how we might use that information. Next slide. So we're also interested in the Priest River itself.
Did you pick specific strains on Priest Lake, or, so I noticed there's anything on where Granite Creek is or nothing like this?
We picked sort of the first priorities based on what we think or thought were easiest to sample. We did go back and do some work on Granite Creek specifically. It is a much more complex place to sample, large part just because of its size. Same reason applies to the lack of work that you saw in the Upper Priest River in that figure. They're difficult places to sample with that traditional electrovision gear. So in Granite Creek, we did go in and try and work with multiple backpack electrofishers to do some description of what was there. We did find brook trout were pretty widely distributed in that stream, in that follow work, with cutthroat at the very upper end. We're interested in the main Priest River itself. So Priest River, obviously is a different place. It's the outflow of Priest Lake. There are different habitat characteristics there because of that. But we have had an interest in what's there and how to think about it. 2 more recent snorkeling surveys have been completed there. So one in 2011 and one in 2019. A snorkel survey is what it sounds like. You get a couple of surveyors in the water with a snorkel and a mask. You have defined reaches. They float through those reaches and physically count all the fish. That's the intent, to count all the fish in that reach. And use that then to describe a broader density of fish across the basin. So all the points on the map on the left represent locations where snorkel surveys have been completed within those 2 surveys. There are some white dots and black dots. We did add some additional sites to the last survey that we did that were identified cold water areas from some work that the Council tribe had done in the past to try to compare what fish densities might be like in what might be a colder water area versus the main river. So these are input areas like the mouth of the East River where you get some cold water coming into that piece of land. Next slide, please. So results from that survey, just very basically, are depicted with the fish on the right. So whitefish are relatively common, one of the most common fish that we see in the Priest River. Second, or not necessarily second, but equivalent or near the same would be the combination of suckers and northern pike minnow. So also very abundant species, followed by a much less dense population of a variety of other fish, including smallmouth bass, west slope cutthroat trout, brown trout, brook trout, rainbow trout, peamouth, the down-game fishes. So once you remember back again to sort of my base description of some of these fish and their requirements relative to water temperature, what you see here are primarily fish that are more tolerant of some of those warmer water temperatures, not necessarily the fish that are needing those colder water temperatures. Just as a comparison, on the left, we've got a figure that describes density of fish from our snorkel survey relative to some of the other populations around the region of rivers where we know we've got cold water and strong cutthroat populations. So the Coeur d'Alene River and the St. Joe River, primarily just the lower ends of each of those, trying to make the comparison a little more preferable, I guess, rather than maybe the headwaters where you might expect to find the coldest area of those streams. And I've also included the Moye River, and I did that intentionally because the Moye is a little bit different stream. If you're not familiar with it, it's a tributary to the Kootenai River. It's located northeast of Bonners Ferry. It's the outflow of a lake in Canada. So it's very similar to its source is through a lake with warm surface water, flows into Idaho. The majority of it is isolated from the Kootenai River by a big waterfall, so it does not have this migratory destination that would be similar to the Priest River, but it does experience some of these warm water temperatures that are comparable to the Priest River. So, in general, just to highlight, West Fork Cutthroat Trout, black bars on the left, located on the right of the figure, considerably lower in the Priest River in our August survey than a similar survey of either the Coeur d'Alene or the St. Joe in that same period of time. No cutthroat there for the Moye River because there aren't. There are rainbow trout, and rainbow trout do exist in relatively, moderate densities, more similar to Westlow cutthroat trout, perhaps in the lower St. Joe River. Other species, like mountain whitefish, are common throughout all four of those rivers, but you'll notice that, again, Priest River densities by the black bar considerably lower in density than all three of those other streams. So, in general, cold water for those cold water fishes means there's a different opportunity for those fish to occupy what would be a larger river system and take advantage of that. A migratory path or destination that might be different than, say, a large lake, like we have connected to the Priest River. And then with warm water, like in the Moye River, generally relatively low densities, similar to the Priest River, although whitefish are a bit more abundant in that system.
You ready?
Yes. Okay, so I just want to kind of wrap up with some historic thoughts, a little bit about fish management of the Priest River fisheries specifically. So if you're not familiar with kind of the structure of the Idaho Department of Fish and Game, I guess would be how I would describe that. We operate under a management plan. So we have a fisheries management plan, it's a statewide plan, it's updated periodically, and it highlights here's what our targets are, here's what we're hoping to do, here's what we're going to be thinking about over this period of time. It's something that's developed with a lot of public input. So we're guided by what people want to see on the landscape. And it also kind of highlights what our key responsibilities are. So I had two come out that just kind of capture that. One is really a mandate to manage for native fish. And then two would be to provide fishing opportunities. Those don't have to be mutually exclusive, but they're two distinct mandates that show up in this management plan. For the Priest River, I thought this was interesting. I guess if you're interested in looking back in time, these are available on our website, and I would wager that the Priest River makes up a relatively small component of all of those management plans in the past. And although it's present in the current one, really the focus isn't as much on the fish that are there, but how do we make fishing better through other means. So there's a reason for that, I think, and there's some history to go with it that's really, I think, shaped the way fisheries managers have thought about the Priest River over time. And I have a few examples just to highlight that stand out to me. The first, and it's super small, I apologize, but there have been some investigations within the system that have helped kind of shape that idea of what the Priest River looks like. One of the first ones that I go through or think about has been sort of the initial investigation of Priest Lake and Priest River fish communities. This was work done by Ted Yorn. He was a student at the University of Idaho. He later went to work for the department, and then following that became a professor at the University of Idaho. He spent a big chunk of time looking specifically at Priest Lake, the fisheries there, how to manage them, and included some work on tributaries to the lake. And I found this interesting that he noted they did not include the river below the lake because it was of little value for cutthroat trout. That was his concept at that time. He went on to say in some of the discussion that may not have always been that way. People reported that there used to be some pretty good fishing, especially in that upper river portion, what would be now below the dam, and that was seasonal in nature. And that the dam itself may act as a barrier when the boards are in, not necessarily when the boards are out, but that may influence fish that came out of the lake, provide some fishing opportunity, and then when they went back, couldn't reach that lake again and disrupted what could have been a migratory pattern that was different than what we see now. So, and I know that Brian's going to speak a little more about what we do see now in that exact location, so that would be interesting.
What was the date of that study?
1956 and 1957.
Which would have been about 6-7 years after the dam.
Right, so not long after the dam. That's a good point. Next. So just kind of following through time, there was some work done in the 1970s, again trying to think about what can we do to make fishing better in the Priest River. One of the captions that I caught from their work is that we went floated the river and we caught only squawfish. And then we followed up with a snorkeling survey and we observed some suckers and some whitefish. Well, really, we didn't observe much, and water temperature was high at that time. They made some conclusions that water temperature was impacting what we saw. They did do some other work where they had some one catching some fish as well, but in general concluded the fishing wasn't very good, and probably because there weren't many fish there and water temperature was warm.
And this was the same year?
No, this is 1974, so this is Richard Yerzak, another fisheries biologist later in time, was thinking about the Priest River itself. I wanted to throw in one thing. We hear often, well, okay, so the conditions there aren't suitable. We're not seeing a lot of fish. Can we stock fish to provide fishing opportunity? That is something that we do. We do it quite often. We use hatchery fish to provide fishing opportunities in many places. And we have it in the Priest River. As I mentioned earlier, we do have a history of stocking rainbow trout in the Priest River through time, although not consistently through time. But there was a concerted effort to understand, okay, what does that really mean in terms of making fishing better? So in the 90s, they looked at stocking rainbow trout catchables. So these are fish that are larger, ready to be on a hook and caught, take home. And they tagged the fish, you'll see a little piece of plastic hanging out of that fish. That's the same way we monitor harvest of fish today, by taking fish and then looking for angler returns to those fish to understand what proportion might be harvested. And they found that very few of those fish were taken home. So 4% of the fish that they stocked were harvested from the population. They concluded that that was not sufficient to use those fish there. They highlighted that they thought a number of things were happening. Primarily, one of them is that those fish didn't stay in the system long. They were being washed down. They weren't fit enough to make a go of it right away after being stocked in this moving water system. That's common actually across Idaho to streams and rivers. We stock very few with rainbow trout today, largely for the same reason that those fish aren't. They don't stay in one place long enough for anglers to catch them. They get washed down. Fitness plays a role in that. Their longevity is otherwise limited as well. So even if they get washed down, they're likely not to live too long in that complex. So I think I'll wrap it up with that, and really I just want to highlight some of the things that I was hoping to point out. One, Priest River fish community really is a blend of native and non-native fish species. Distribution of those fish is influenced by a specific species trait. So this temperature tolerance. Cold water fish are primarily in the tributaries to the Priest River, whereas the Priest River itself houses some of those fish that are a little less susceptible to warm water. There's a resident and a migratory life history type in fish, native fish in the system. I'm talking about salmonids, and that in part is likely influenced by water temperature. And I guess in highlighting that, I'll point out that bull trout and West Slope cutthroat trout do exhibit these migratory behaviors, and that does mean that they are in the Priest River for a portion of time. It's a migratory corridor. They're using it to get from one place to another. So there is a period of the year, spring, or potentially late fall, where those fish do use that system more broadly. I believe we will find we've got fairly strong native fish populations and suitable habitat, so the tributaries to the Priest River. And again, Priest River is a migratory corridor, but in general, outside of those migratory periods, we've got relatively low fish abundance, especially for those fish that are cold water fish. And those limitations from the Grease River are really primarily temperature, and that has influenced our focus on providing recreational fisheries or thinking about recreational fisheries in a management context over time in that. Yes.
Since temperature is such a big factor, you said, I think 60 to 65, I've seen studies by, or releases by Department of Fish and Game, and also DEQ that more like 57 and 59, more like 13 Celsius.
There is a range, and that's true. I think one thing to highlight is the difference between where populations are productive or individuals are productive and where temperature becomes a limiting factor. So, yes, I think colder, especially for bull trout, I think that would be appropriate in many cases to say lower is better. Broadly describing the range that those fish are active and able to function well. The challenge becomes when you get into some of these upper temperatures, 70 and above, and you hit these temperatures where now stress is at a level where mortality does start to play a role. And again, I think the issue there is not necessarily as much the short-term periods of hot water, but the long-term extended periods where you've got weeks, months with water, early hot water. An afternoon, a couple afternoons without water happens in most of our streams throughout the week. And a couple of trout do well, full trout in many cases do well.
So, the other question was, I've also seen a Fish and Game study that said that minimum stream flow for each species goes on 200 CFS. Is that a factor?
I think it could, so minimum stream flow is just one base slope provides sufficient room essentially for fish to do well and not limit the population. Pretty sure you're referring to Cindy Robertson's work on the Grease River, and I think she did indicate that there was a minimum stream flow that was around 200 CFS that they felt through their modeling were limited the abundance of fish in the Grease River below that point. And I think that's a fair point. Grease River has other issues with stream flow, especially when we have really dry, hot years. And that's true of any stream. When you limit water, you limit the abundance of fish that may be present. That doesn't limit the presence altogether, but rather the abundance, unless you then run into these temperature issues where you've got excessive temperature. I think that would be nice. Sure.
Sorry. Microphone is already in.
Am I up? You're up. What do you know about how the current river differs from what it was historically? I mean, a long time ago, 150 years ago. Very little?
Very little. It's tough to know. I mean, what we know are annual reports that fishing used to be better. There can be a lot of influences to that. I mean, certainly the dam and its potential influence on migratory patterns broadly cutthroat probably don't do as well now as they did pre-development. I think that's a fair thing to say. We still have relatively robust cutthroat populations that use lake ponderay and Grease Lake. Are they the same as what they used to be? It's tough to answer that. I think it's reasonable to think that a collection of development has changed the way streams operate, land use, fish harvest perhaps, and some of them will, many things have influenced how abundant cutthroat are, probably not as abundant. But to go back 150 years, it's tough to say. I guess that, one of the things that we rely on at that point is a lot of verbal history. So what were the experiences of council back in those days? And we heard previously about their use of the river system, but it's tough to know.
Hey, Rob. Okay, time for one more question.
I got one, please. The rig out here, both windows are down and it's pouring
The silver like Chevrolet.
Oh, yes.
It's pulling.
Bring on down.
Okay.
I think we're over time, so we just move on.
I just want to make sure we have time for everybody, and we can come back to questions at the end if we have extra time, but, thank you, Rob. That was really informative. Yeah. All right, Joe, you want to take it? Introduce yourself.
Well, hi, everybody. My name is Joe Crawford, and I'm a fishery biologist in California. And most of my work in the past has been revolving around studying the migratory life stage of cutthroat and Bruce River. So, in my year with Council Tribe, I took over from the work of Todd Anderson. If many of you people may be aware of who he was. But he began this work roughly in 2014 in that region. So I've kind of taken over for him. I've moved on and I've continued that work as well. So I'll give you a little presentation about that.
All right.
I'm just gonna double check this machine here.
The previous operator.
It's really satisfying to determine this operator here. So you just have to push that button quite substantially.
It's really
And then you've got it at each one. So.
yeah, I'll try to do better.
Otherwise,
Can you do it?
Those definitely make things easier. All right, let's go ahead and jump into this. So to start off with, I thought I'd give a little bit of background on the tribe. So for starters, prior to 2010, we didn't really know a whole lot about West Slope cutthroat within the Lower Creek River. At least the Council Tribe didn't. We knew that they were there. We knew that there were migratory populations, but as far as population trends, how many may migrate, we weren't quite as sure about that. However, that changed in 2010 when several tribal biologists actually came across a congregation of cutthroat at the mouth of the Bruce River where it joins the Pond Red. So this was during a routine electrofishing survey, and it was very interesting to find these fish because we didn't really know where they were going. We figured they were a migratory population that was undergoing spawning migration, but we weren't quite sure where that was occurring. So this seemed to us to be an excellent opportunity to start doing some research to find out more about these fish. So the following year in 2012, the tribe actually went out and videotaped 55 little cutthroat at the mouth of the Bruce River to see where they went for their spawning migration. Now, this was done using what's called a radio tag. So radio tags are essentially similar to a GPS tag where using antennas and the tag itself, there's a signal sent between the two. So the antenna, if you point at the fish or at the tag and it's in the general vicinity, you can get a general area where that fish might be. So these antennas can be handheld, they can be mounted on planes, they can be mounted on a truck. So using that data, we were able to track where many of these cutthroat went for several years. And so after several years of studying their movements, we discovered that many of these fish were entering tributaries of the Lower Creek River for their spawning. So the majority of these creeks are quite small. I mean, they're the kind of creeks you could just step across in 1 or 2 bounds. And it was pretty neat to see many of these fish moving into these teeny tiny tributaries. So now that we knew where these fish were going, we decided that we wanted to do a little bit more research on this population, see how many there were, population trends, some of the timing of the migration. So to do that, we actually went into several of these tributaries and we set up what are called inclined plane traps to try to capture as many cutthroat as possible and to tag these fish. So before we get into too much more detail on that, we'll do a little bit more detail on which creeks these were. So through the tracking of these 55 adult cutthroat, we ended up finding that very few, or actually I believe not any, went any further north or further upstream from the mouth of the East Priest River, which for those of you who are not familiar, is about halfway up the Priest River. It's one of the larger tributaries, but we saw that no cutthroat actually moved beyond the Priest River. So
we focused the majority of our effort downstream of that river mouth. So we ended up choosing several different tributaries for a couple of different factors. So these tributaries being Saddler Creek, Sanborn Creek, Quartz Creek, Big Creek, and Bent Creek. And these tributaries were chosen for a variety of reasons. The biggest being this is where we had mapped a decent amount of entering and undergoing spawning. The second being access. A lot of these lower Creek River trips rely on a lot of private land, so access was an issue. And additionally, we're hoping to see where the majority of these fish went. So that being said, move into
Come on, come
oh,
on.
man.
I'm on it.
All right, thanks.
Gotcha.
Okay, so a little bit more detail about what we did with these tributary traps. So the traps we chose to use for this work are called incline plane traps. And now these were originally designed to be used in like medium-sized salmon rivers in Southeast Alaska, but we were able to retrofit them to work in these small Creek River trips to capture migratory cutthroat. So for the most part, we began dropping these traps in annually in 2014. Although early on in the project, we were using a different trap design. However, this incline plane trap design was incorporated in 2019. We had much greater success capturing cutthroat once we were able to integrate that design. So when we capture cutthroat in these traps, we do several different things with them. We implant them with what's called a pit tag. And for those of you who are not familiar, pit tag is essentially a microchip that's injected by a needle into their abdominal cavity or their backbone area. And essentially what that is, it's a 15-digit code that's a unique number unique to that fish and that tag. So it allows us to identify specific individuals with that tag. So we implant those cutthroat with that. We take weights, we take measurements, and we also collect genetics. A little bit more on that later, but refers to the study that Rob described in our work by IDOG, Eastern Washington University. So back to the pit tags. These traps are actually paired with what are called pit tag arrays. So these arrays are placed just downstream of the trap, and essentially what they do is the cutthroat that we have a pit tag in actually migrate out and pass underneath these arrays. And when they do, that tag is detected as they pass underneath, and that tag is sent to a data logger where it has a record of these fish passed under. So with that, we've actually been able to document adults that have returned in successive years, spawned multiple times. We've actually been able to tag small migrating juveniles as they're migrating out from the life history stage that Rob described. And we've actually captured many juveniles that actually have returned several years later as adults, which is very interesting. So we can compare and actually get growth rates, sizes. Question?
Sorry, I'm halting, I can't receive because I keep thinking, what if someone went fishing and they caught a fish with this GPS chip? Will they know it? Will they eat it?
So the question was, there's a nice young lady in our audience who was curious whether these small microchips, if somebody was to harvest a cutthroat and eat them, that tag, if ingested, can be an issue, or you bite it, and that is certainly something that could be an issue. These tags generally are very small. They're smaller than the size of a Tic Tac. And where we implant them, it's in their abdominal cavity, where, for the most part, in a more broad sense, it's where their guts are, like their organs and such. So it's not actually in the meat of their fillets. So unless you're eating their liver and their stomach, which most people, I don't believe do, but I feel like that's fairly unlikely to happen. That's a good question. So, and it's not legally done, by the way. Clarification. So to jump back into this, so with that, using those pit tags, we've been able to basically generate a good idea of how many cutthroat move in and out of these creeks every year. We've been using those to generate how efficient our traps are, and we're hoping here in the future to be able to estimate the abundance estimates and how many juveniles migrate every year. However, to be able to do that, we have to tag a large number of cutthroat, which we've struggled with in recent years. More on that soon as well. So these inclined plane traps are, like I said, placed in the first week of April, and they're typically there until about the middle of June. We monitor them every day, visit these traps, and as soon as our catch dies off, we pull the traps and no longer operate them. So, and these pit take arrays are actually operated March or November, so we get a good idea of cutthroat movements throughout the season besides the winter. So. Okay, so now we're going to move into a little bit of the results from the studies. So this one, I will go into a little bit of detail of, although Rob did a fantastic job at describing these migratory cutthroat. So, but essentially, like he described, there is a population of adult West Slope cutthroat that reside in Lake Monterey. However, they live what is called an affluvial life history strategy. And in essence, these adult cutthroat migrate from Lake Monterey down the Monterey River, up the Priest River, and into the Priest River tributaries, where they then spawn. Following that, these adults migrate back out of the lake if they do not die in their spawning action. And following that, the juveniles hatch out. They typically spend several years in these creeks where they rear to a certain size before they out-migrate. And following that, they out-migrate to Lake Monterey, grow up to be adults, and once they reach maturity, begin the cycle again. So it's we've learned quite a bit about this using these pit take arrays. So next slide. So just a quick little figure that describes some of the out-migration timing of these cutthroat. So every year when we tag these cutthroat in these traps, we also get an idea of when these fish are exiting the creeks. So what we see is the majority of adults actually out-migrate in late April and early May, and the majority of our juveniles actually migrate in late May and June. So it's interesting to see this gap in between when these fish are leaving these creeks to return to Lake Monterey. Additionally, this is a slide that describes our trapping numbers through kind of our big three tributaries. Of course, Sanborn and Sadler Creeks. And these are basically adults and juvenile, or these are juvenile cutthroat that we trapped and tagged in these tributaries throughout those years. So generally, I should paraphrase this in that early on in our study, we had difficulty in, like I mentioned earlier, capturing enough cutthroat in our early trap designs. So we weren't particularly effective at capturing enough cutthroat until roughly 2018 until the present. So when you look at 2018 and Gorge Creek does not have a value, we had not placed these new inclined plane traps in that creek yet and had not captured as many fish. However, you can see in 2019, after we placed these inclined plane traps, our catch rates were very, very good, but in the preceding years, they have declined. And we have some hypotheses on why this might be. Water temperature being one. There's also ideas floating around that perhaps our traps themselves may be interfering with spawning migrations. So that is one of the things we are considering changing in our study design currently. So now this next slide speaks more to what Rob described during his presentation regarding cutthroat in Lake Monterey and where those cutthroat originated from. So this figure actually came from the research done by a grad student, or several grad students at Eastern Washington University, and it describes the proportion of cutthroat caught in Rob's work that they did in Lake Monterey. And essentially, of 96 cutthroat caught out of Lake Monterey, 35% of those cutthroat from the lake came from the Priest River. And even more interestingly, if you look at Lake Monterey, the tributaries of Lake Monterey only accounted for 37%. So nearly as many fish in Lake Monterey, or cutthroat from Lake Monterey, are originating from the Priest River. So it's very difficult to describe how important the Priest River is to cutthroat. The Priest River locally is incredibly important to cutthroat regionally. So any differences in abundance or levels of cutthroat we see in the Priest River, we would expect to see changes in Lake Pend Oreille. So it's very important to take care of these fish and monitor these populations. So.
Yep.
Now,
Okay, yep.
thank you. And so I'm going to give a little bit of summary of what we already talked about. So essentially, adult western cutthroat enter the lower Priest tributaries in early March. Spawning occurs typically in late March and early April. However, depending on the year, there can be a give or take of a few weeks. It seems as though the big driver for cutthroat migration into these tributaries revolves around stream flows. From what we've seen, the majority of these cutthroat enter the tributaries during high water events, whether that be snowmelt or rainstorm. Additionally, after spawning, the juvenile cutthroat, which would grown up in the most recent spawn, spend 2 to 3 years within these tributaries, rearing and reaching a certain size, which when they exit tends to be 4 to 8 inches. And as you saw from our figures, they tend to exit in May and June. These juveniles, after they out-migrate to Lake Pend Oreille and return, they usually take 1 or 2 years to come back. And they average 12 to 16 inches, although we have handled up to 20-inch cutthroat in some of these teeny tiny creeks, which is pretty incredible. So, additionally, we, using our pit take returns, have been able to document repeat spawning, and this includes spawning events in subsequent and sequential years. We had several cutthroat in 2020 that spawned and entered these tributaries, and then returned in 2021 to do the exact same thing, which, as far as salmonids go, can be relatively unusual. So, additionally, as we talked about before, an affluvial life cycle of migrating from Lake Pend Oreille to the Priest River is present in these fish. There are several resident fish as well, as Rob mentioned, in these creeks, and we run into them occasionally, although it is hard to distinguish them from out-migrating juvenile fish based on size. Another interesting data point is the fact that annually, Avista takes, not annually, but over the course of their studies, Avista has taken several hundred Westlow cutthroat below Cabinet Gorge Dam in the Clark Fork River, and we detected some of these cutthroat that Avista has tagged all the way up in the Priest River tributaries. So that's a 90-kilometer, 55-mile migration, which for a 12 or 14-inch fish, that's no small walk. So it's very interesting to see. As we talked about before, the number of out-migrating juveniles we've been seeing in these Priest River creeks over the past 3 years has been in decline. The 2023 data was not included in this presentation. We just finished up our trapping today, coming from the field. But the 2023 returns have been the lowest in project history. So one of our suspicions is the majority of these juvenile cutthroat that are in the tributaries that would be out migrating this year, we would expect to be in the creeks and just hatching in 2021, which is when we had that 118-degree summer. And it's suspected that many of these fish may have perished in the creeks due to the high water temperature. That is the fear. And of course, kind of to wrap it up, we talked about how important Priest River cutthroat are to Lake Pend Oreille and the greater Pend Oreille drainage in general. So we need to take care of these Priest River fish, and there's still lots of research to be done. So that's just about it. So anybody has any questions?
Thank you for your presentation. So I'm just curious, Fishing Game or the Castle Tribe have any, data information on what percent of the Lake Pend Oreille bull trout population spawns in Priest River tributaries? Like, you've got a ton of information on cutthroat. What do we know about bull trout?
The Kalispel tribe has not done a whole lot of research on bull trout in the Priest River Basin. I don't think I can speak to that. So perhaps Rob could give you some enlightenment.
I don't have the figure. We do have some baseline genetic information on bull trout that's been used to describe abundance in Pend Oreille and their origin in a number of ways. It would be relatively low. There are actually quite a few spawning tributaries for bull trout around Lake Pend Oreille where there's only that one singular one with really a population of bull trout on the Priest River. Small, I guess, a small portion.
Yes, question?
So we see that a approximately a third of the cutthroat cotton Monterey are migrating to Priest. It's interesting with all the tributaries in Monterey, do you have any idea how many are going into those tributaries to I guess maybe balance that percentage?
So the question regarding how many cutthroat may be entering the Lake Monterey tributaries as compared to the Priest River, and if we could pull that figure back up. So that Lake Monterey percentage, which was I believe 37%, is the number of fish coming from the Lake Monterey tributaries. So nearly as many fish are coming from the Priest River as from the Lake Monterey tributaries, or originating there.
Really amazing. You'd think there would be some reason for that. The fishery gotta be smarter than that, right, Ron?
They're all going to be able to get more freeze. Just to highlight that the Pack River and the lower Tarpon River do encompass that broader Monterey and tributaries to it. They're just broader basins within. So the genetic study that was done sort of the Monterey and Lake Monterey tribs are some of these smaller ones that are individual direct tribs where Pack River actually incorporates I don't know how many, a number of other tributaries in there. So I don't know, whatever that collected percentage is higher than 37%, so 47, 60-ish percent.
What percentage would the Gold Creek tributaries, it's the southern end of Pond Rate?
That's within that 37.
Okay, all right.
Any other questions?
One more. The lower streams that you tested in Priest River are typically not considered cold water streams. Is that correct?
I don't know if I can speak to that either. They are, they're heavily impacted streams. Sandborn Creek in the upper reaches is agricultural, which I can't imagine it was previously. However, the mouth of it also goes dry in most years. We haven't operated any temperature loggers in these creeks, but typically these creeks also have resident cutthroat, so they're able to crack it cold enough water to be able to support these populations. So
we don't have any designated cold or warm water streams in pretty much North Idaho. May not be reality, but they're all supposed to be cold.
They do get warm.
I think we can give a couple more questions and we'll still have time.
question here.
Well, first of all, we got to looking at some data that you guys provided on the tribe provided on where they modeled water temperatures in the creeks.
Mm-hmm.
And there's a big variation in Murray Creek is by far the hottest. And as I recall, Quartz Creek and maybe Sandborn or among the coldest.
I know several of the Quartz Creek tributaries, and Quartz Creek itself is one of the colder creeks we work in. I don't work particularly close with the temperature data. I work mostly with the fish data, so I don't know if I can speak to that either.
So my other question was going to be, what puts the fishery, specifically the cutthroat and bull trout pork, at risk? Water temperature, water quality, water quantity?
Well, I'd say so. The question was whether West Slope trout or bull trout, if it's they're more sensitive to water quality, water temperature, water availability. So in response to that, I would say that for the most part, all those factors play a role. I can't say any one of them speaks to others any more than the others. Cold water temperature is especially important because you can have habitat, you can have food, but if cold water's not there, I mean, these fish can't survive. It'd be like filling a room full of a good buffet of food, but there's no oxygen in the room, so you can't really do much of that. Another question.
Does the tribe or Fish and Game have any plans to do any restoration or habitat, projects on Priest River coming down the pipeline?
As far as new upcoming projects or continuing research?
Just habitat improvement projects based on the data that you're gathering and.
I can't speak to IDFG.
the Kalispel tribe, we continue to do several temperature research stations and operate monitoring station temperature-wise. As far as habitat goes, I'm not aware of any. We'll let Rob speak for Idaho Fishing Game.
Yeah, so I think some of the inventory work that I described very briefly will help us identify where we might have opportunities to do habitat work. And one of the things I failed to mention, and I need to, is that there are partners in that inventory work that include the Kalispel Tribe and the Forest Service. And very specifically, the Forest Service, I'm pointing at Brandon here because he's one of the staff there that works with water specifically, are doing habitat projects quite frequently. I don't know what their list is, but some of those include things like culvert replacements that open up fish passages for migratory fish or limit sediment input. Those things are ongoing, and I'm sure they've got a list of projects to come or potential projects. But again, I think some of this inventory work will help us identify where we might seek out some of those opportunities that could benefit native fish, but probably fish and depth.
Yes, one more question.
Good. I have to explain for a second what I'm trying to ask, but I live on the Priest River. I'm about a mile upriver from Sandburn Creek, or maybe a mile downriver from 8 Mile Rapids, so give you an idea where I'm at. We've had Dynamo appear probably almost 18 years ago on the river in front of us. Well, Rob, when you were talking, you were saying how important the reds are for the bull trout as a place to lay their eggs. Well, the Dynamo, for those of you who don't know, it's also called rock snot. It's like brown vomit. It's about a 1/4 inch thick, and it covers the entire stretch of the river where we live, probably an 1/8 of a mile north and 1/8 of a mile south, all the way across the river. So the bugs and the fish and the things that require crevices between the gravel so their eggs can land in those crevices and pupate or do whatever they do. So here's my question. I'm going to kind of set it up. Is anybody studying where there are Dynamo infestations up and down the Priest River? I'm sure that we're not the only place, and I've heard that it's also appeared in Kalispel. I see, isn't this a huge threat to spawning fish and eggs and the other things? Is anybody studying?
That could address that a little bit.
Oh, I don't know Dynamo populations on tributaries to the Priest River. I know there's Dynamo on the Priest River quite a bit, but are we seeing cutthroat spawning on the actual main stem, like Priest River?
No, not particularly. No cutthroat spawning has been documented in the main stem. There's been some suspicion, but no documented cases.
And I don't know for sure on the tributaries in Dynamo, but I just know from my observation I've seen it on the main, but not the trace so much. Todd, what were you using?
I was with DEQ, my boss, Surface Water Department, he's mapped quite a bit where the Dynamo is and been studying it too, so we're pretty aware of it.
I think we should move on questions. I have one, but I'll come back to it later.
Okay, sounds good. Move on to Brian now.
Thank you, Joe. That was super informational.
Molly, my operator.
Okay, first I have to find your slideshow.
Well, good evening, everybody. Thank you, Joe. Thank you, Rob, for your excellent background information. My name is Brian Whitty. I'm a fisheries biologist with the Kalispel Tribe, and I'll tell you all a little bit about myself. I grew up 3 hours west of here in Greater Washington. I've always had a passion for water, fishing, the outdoors. Right out of high school, I did 2 years of concrete construction. I decided that was not for me, so I went to school. I went to Eastern Washington University, go Eagles, where I earned a bachelor's in biology as well as a master's in biology. And I started work for the Kalispel Tribe as a fisheries technician in 2017, and later in 2019, I became a fisheries biologist.
It's coming.
Mm-hmm. We're so close.
More about yourself.
Yeah.
What's your favorite song?
Oh, give me shelter by the Rolling Stones.
Ah.
That's not it, huh?
Wait, this is his.
It is? Okay.
This is
No.
you? No,
This
this
is
is.
me?
Is this yours?
This is my
Okay, I
That's my
apologize.
name?
Okay, good, sorry. There's just so many fish
got
pictures, you know. All have the same title, similarly. Okay.
In my presentation, assessing fish passes and outlet dam and radio tagging Westfield cutthroat trout. This is a project I worked on as a fisheries technician. It's actually one of the more interesting projects I've ever worked on. And as part of this project, there's a story I will tell you that is one of my favorite stories to tell. So, next slide, please.
Believe it or not,
Go on, operator.
I don't have that.
It's like, how is it there?
Okay,
But nowhere here.
Okay, new share. This is him. There you go. We're gonna.
This seems to be a good study for you if you know concrete and fish.
Yes.
It's saying it's paused. I think it's the internet.
We're hitting.
I'm not gonna talk about the fish on the fish here. This guy is a West Loaf 10, the Priest River. This is actually cut that I caught in the Priest Lake. That was 20 several years ago.
Let's click there. I did.
Beautiful fish.
I'm gonna stop share.
We're gonna stop sharing and start again.
This is him. Yeah. I'm gonna try again. Okay, it's so happening now. Hold on, from beginning. The internet is truly causing problems.
Everything's like slow.
It says we're sharing it.
There's no venue in Priest River that has all the pieces that like work. That's in the, you know, it's like you can get the right time, but
I'm just gonna try a new share.
What?
I'm just gonna try share.
You could try the remote again. Wouldn't that be magical? It's just like what we're seeing on here isn't actually court. Like this is like live.
Well, undergo the opposite, maybe I
I did that, I think.
Good job.
kind of wing it.
It's not even what I see on my screen, so
So what I'm going to be talking about, I'll go into a little bit about Priest Lake, Lower Priest River background in regards to large cutthroat trout. I'm really going to go into detail about the methodology we used for answering the question, is outlet dam an upstream fish fair? And so as part of this detail, I'll talk about how we decided to do what we did, how we caught fish, how we tagged them, how we tracked them. Then I'm going to talk about our results. So what happened to these tagged fish? Where did they go? What did we learn about fish passes through outlet dam? And then some conclusions from that, and then I guess the very tail end will be questions and answers amongst all three of us presenters.
Wait, what was your favorite story?
Favorite story? Oh, as far as, yeah, the D&D, I can go ahead and wing this. I mean, this is actually, I can pretty much tell the whole story on my favorite situation, if need be. So, essentially, Priest Lake is home to large cutthroat trout. There are cutthroat trout in excess of 20 inches that live in Priest Lake. Outlet dam at the bottom end of Priest Lake is operated to maintain lake level during the summer for recreation. And so we've always assumed that when the gates on Outlet Dam are open, the river's free flowing, fish can freely pass back and forth. But what was not known was when the dam was operated for maintaining summer lake level, can fish actually get upstream through that? And in this image, you can see dam was closed, water was shooting out of the base, high velocity coming out through that. So when you look at it, think, well, maybe if fish can get through there, maybe they can. I mean, fish can get through some pretty crazy stuff. So, as we know, Priest River does get very warm in the summertime. There's been In 2021, I documented fish kills in the summer.
Yeah, this is his.
If I were cold water fish such as West Slope cutthroat trout that leave Priest Lake into the Priest River, they're in the Priest River before the dam becomes operational, they're stuck in there, and they get back up through the bottom of the outlet dam. So we decided to go and capture fish out of Priest Lake. How we captured fish was with the best method available as any. They can all agree that's the best way to catch fish. Okay, for sure. We captured 20 West Slope cutthroat trout out at Priest Lake. We went out in June of 2018. Our first day out fishing, we fished around the islands, around Kavanaugh Bay. Didn't really know what we were doing. Caught one smallmouth, but that's being concerned about getting 20 tags out. You know, I understand the cutthroat trout is a bit of a bug eater. So I was looking at the map of the lake, looking at Coolin Bay, Olive Bay, caught my attention. And sweet, there we go.
You did something.
I know.
All right.
Yeah, so I was
Wait,
basically
it's working.
Yeah. I discussed all that information there. We can go to the next slide.
Oh,
All
this
right.
is like,
I'm kind of getting too far ahead.
I don't even understand how.
Yeah, so we went out and we ended up catching 16 cutthroat trout in the month of June from largely Outlet Bay and Coolin Bay. We did this by fly fishing. I have no shame, so we did throw spoons, jigs, gear, all that sort of stuff. And what we ended up doing was, of these 16 fish that we captured in June, we radio tagged them. So we decided telemetry was the best, so we decided to catch fish, put these radio tags into them, release them in the Priest River, below Outlet Dam, being used to maintain the level of the lake. And we decided on radio telemetry for a variety of reasons, but for those of you not familiar with telemetry, there's two main components to it. There's a transmitter, it's a message signal, and then that signal is picked up by a receiver. A receiver will decode the tag associated with the transmitter, log that tag, date, and time. Transmitters or tags consist of transmitter and battery. Transmitters will go off at specified time frequencies. There we go, perfect. Great. So as I mentioned, you know, we 16 fish that we caught in June. We did actually go out in September and captured 4 fish along the shoreline of Kavanaugh Bay later on. But this is good. So here's what a tag looks like. So the actual back little dark part is the actual transmitter, and then most of this tag is the battery, and it's encapsulated. There are 2 types of telemetry. There is acoustic telemetry and radio telemetry. We decided to go with radio telemetry because acoustic tags in a river environment, shallow, that signal bounces around all the rocks and just dissipates. Whereas the radio tag, that signal actually comes out of the water, goes through the air, and you can pick it up with a receiver in the air. And these radio tags have a fairly lengthy antenna coming off, as you can see from this tag fish. So the tags we used were radio tags, battery life is 400 days. How we got these tags into fish was minor surgery. So what this looked like was we captured fish out of Priest Lake, took them over to the Priest River, either at big sheep or white-tailed view, and we anesthetized these fish. So we got cooler water mixed up with anesthetic solution. The anesthetic solution we use is a common chemical, MS222. It's essentially like if one of us was going in for surgery, we get anesthetized, and then we make an incision along the abdomen of the fish, usually maybe a 1 to 2 inch incision. Take a hypodermic needle behind that incision, and actually place the radio tag to the body cavity of the fish. That long antenna would go up the hypodermic needle, pull the hypodermic needle out, do 2 sutures to suture out that small incision. You would then take the fish, put it in a cooler of water with no roots in it to come to, once the fish was upright, swim around, we would release them into the Priest River. So, anyways, like I said, 8 fish that they can see right in white-tailed view. The other 4 we caught in September. We put them at the outlet graft. There we go. That moved. For tracking these fish, with this via a raft and truck. So the receiver is kind of like a little computer, and then attached to the receiver is an antenna. So these are images. Here's a handheld antenna at the bottom end of the screen, right next to the fish, next to the rock. Here's a truck mounted antenna. So between June and November 2018, I would go out once or twice a week and essentially would raft from Outlet Dam down to Whitetail Butte. And then next day I would take the pickup and just drive around the Priest River. So do a loop on the 334 road up and around. The data that we would collect on these tagged fish would be, once we got over a tagged fish, record coordinates, would record the depth the fish was at, temperature of water for each located fish. And since we were doing this in the summer low flows, oftentimes we could actually see the fish there. We could see the radio antenna signal. For the truck tracking, it was just another step. So once I would pick up a signal from tagged fish, I would detach the cable from the antenna, put on the handheld antenna, walk through the woods, and then I'd go along the river until I pinpoint the fish. There was one time I scooped at the moose doing that. So other than that, I've seen them doing that. So that was our methodology. In addition to this mobile tracking, as I described, we also had 2 stationary receivers. We had one receiver at Outlet Dam and one at Least McAfee Falls Road. So these are powered by solar panels. So if a fish comes by within range of the antennas, those stationary receivers record late time. So here are our results in a nutshell. So I have 2 maps on the screen. The left-hand map is the Priest River from its outlet down to about Big Creek. The right-hand side is Priest River from about Big Creek to the mouth. You will notice RKMs on this map, so it's river kilometers. So how this laid out is river kilometer 0 is down at the mouth, river kilometer 70 is up there at Outlet Dam. These yellow squares are stationary receiver locations, so that's where the stationary receivers are located. Then I also, in bold text, have major tributaries of red stars that denote where fish would hang out. So, like I said, we want to know, can fish get through Outlet Dam? So of these first 16 fish that we captured in June, 12 of these fish approached Outlet Dam in summer of 2018. So they got up there and they did not get past it. As the river warms in 2021C, fish left Outlet Dam area and resided in several cold water refugia. And these are donated by these red stars. So the pool area mouth of Bernards Creek, there's a spring at RKM 47.5, another spring at RKM 43.5. One fish actually did go about 300 meters up the East River and stayed there all summer. And there was also several fish that would reside in river kilometer 30, which locally is called Lake Fishel. It's downstream of Big Creek. There's also an additional spring in river kilometer 24. There appeared to be high in river mortality. We recovered 8 tags from this first group of 16 fish. So what this looked like was tracking and picking up the signal of a tag. The signal's coming from somewhere on the ground, not the river. And then get, within kind of like a circular space from it, and then find the tag. Oftentimes there will be fish bones next to the tag, so likely these fish come to predation, maybe from mammal, maybe from bird. And we also tracked an additional tag to the business. So these first 16 fish, 9 of them perished. And now the 4 fish that we caught in September. So like I said, we wanted to get 20 tags out. We only got 16 out in June. Lakes started getting more. Went out in September 24th and 25th. And we actually caught 4 fish by short fishing. We pulled off on the pullouts on Capital Bay and just fished along the bank. And these 4 fish, we released them at the Outlet Dam raft put. So 3 of these 4 fish remained by Outlet Dam until October, and then 1 fish guess he decided to become a river fish. He just boogie on down to the Northeast River. As I was saying, weekly, I was going out, manually tracking, downloading data off of these radio receivers. So this is where the story's coming. So I promised all you guys I'd tell. So I was going, of course, this summer into early fall, doing my weekly rounds. These 3 fish that we caught, we capped on bait, put up the outlet raft, put it, they're hanging out right there at the base of the dam. So I pull up, pick up with the antenna, I hear the chirp of the tags on the receiver, fish are there. So, according to our data, between October 15th and October 19th, 3 of these fish passed up through Outlet Dam. I have a figure of a hydrograph of the Priest River during this time frame leading up to this. So, early September, so the river is around 100 CFS. It's bumping up. And then around October 15th, the dam is no longer being utilized to maintain the lake for summer lake elevation. Everything's opened up, the river is free flowing underneath the dam. And that coincides with these fish leaving Outlet Dam. So I show up 3 days later, there's no sure going on, it's October 22nd, and I see what it looks like. The flow is just below 1,500, 2,000 CFS at this point. Apparently it peaked around 2,000 CFS. There's no tags there. I see no tags on the receiver except for October 19th. So I call my boss at the time, it was Todd Anderson. I said, hey man, these fish are not here. I suspect they went up into the lake. As I said, radio tags are really good for shallow water environments, but they're not really good for really deep water environments. So we all know Priest Lake is very deep. I didn't really think there would be much chance of picking up a radio tag if I was driving along shoreline of Priest Lake, but I decided to do it. So I took the pickup up along the east side of Priest Lake, going down along Capitol Bay, and I hear the chirp of a tag on the receiver. And it's getting louder, louder, louder. So I pull off and roll the pole house. And I detach the cable from the truck antenna, grab the handheld antenna, walk along the shore. Chirp is like really, really loud. And I'm thinking, I still don't see this fish. What is going on? And as you come through, that surface is like 10 feet off the bank. That's above. And as it's descending, I see the antenna of the tag just trailing behind me. And I'm standing there with the antenna out, just dumbfounded. Sunny day, flat water, where the lake's about 4 miles wide. Here I am, just saw a fish that we had caught about a month earlier, tracked up to here, and it was pretty much like within like 100-meter stretch of shore that was caught before. The story doesn't end there. The other 2 fish, I did pick them up further up the road, but I did not get as close as I did now. So that was exciting. Those 3 fish made it up throughout the dam. So I'll get to my conclusions. It appears that Outlet Dam is an upstream fish barrier while the dam is operating to maintain summer lake levels. When everything's opened up, fish is free to go through, but in summertime, it's no go for going upstream. Oddly, the remaining tag fish, so we did continue this through the fall. We basically had our stationary receivers run through the winter, run through the following spring. We did do mobile tracking the following spring. Oddly, the remaining tagged fish never returned to Priest Lake. There was 4 fish that we pick up in the Priest River periodically. There was 5 fish that just disappeared after the we don't know where they went. We did, so the range of these radio tags can be about 200 yards. It is possible if these fish did bogey out further into the greater basin, Palm River, Monterey Lake, we don't know about it. So yeah, those 5 fish is kind of a mystery what happened to them. And while doing the manual tracking, floating on the raft, it became apparent to me that these cold water loving fish, they become concentrated in cold water refuges in the summer. So that is like a spring mouth, which typically just has sandy bottom, no overhead cover. You would see suckers, snags, various trout, whitefish. With fish being concentrated in these little pockets, it it may make them susceptible to predation, especially if there's no overhead cover over those cold water pockets. And while rafting, a lot of the big stretches of the river would be dead. You wouldn't see any fish. You took cold water pocket, you would see stuff on the next thing. So, those are the conclusions we came from this. I would like to acknowledge the Council of Tribal Resources Department staff, Todd Anderson, Jason Olson, Jason Connor, Brandon Rossley, and Tyson Gold. These are all folks that helped out with this work. And before we get to questions, it's like often my perspective of spending time out there floating the river. While we were floating, I had a fish in the lake, of course. And I saw so much juicy water, deep pools, log jams, you name it. Drift lures to there, nothing happened. And I was disappointed by that. Like, what's going on? And as I learned about the whole area, I thought, this is crazy. It doesn't have to be this way. And I know that we all here may not agree on stuff, but I think we can all agree that fishing water with no fish is stupid. That's all I got.
Oh, thank you.
Questions?
I have a question. So we heard earlier that the migration pattern is generally stops at the East River, comes up the East River. That's the case, then what is the significance of whether or not we pass the dam?
So the question was, from previous presentations, fish come up the Priest River as far as East River. What is the significance of fish passes through Outlet Dam? So there is a migratory, I would say the significance of Outlet Dam is there's a migratory population of cutthroat trout that exists in Priest Lake proper. So the streams that flow into Priest Lake and Upper Priest Lake, there's a whole dynamic going on there of cutthroats that spawn those trips at Priest Lake and live in Priest Lake. If those fish from Priest Lake get into the river before the dams we operate for summer lake level, there's potential that they don't get back into the lake and perish. So that's one concern. Yes.
Are there any, is there any kind of potential mitigation, like fish ladders, or, I know Outlet Bay gets super hot, and it's fascinating that they would go that direction, because Priest River actually gets colder as you go down. But you said 12 of the 16 tag fish went, that's 75%, but they're trying to get back into the lake.
Yes.
And I just appreciate the tribe funding this study as well.
Okay.
Some of those fish are independent thinkers.
Yes. Well, I think, so I guess I'll caveat the study, we're interested in the fish can get up through Outlet Dam in the summertime. This is also going on with, we do know that there are cutthroat trout that reside cold water pockets in the summertime. And previous to this lake study, we were attempting to capture fish that had radio tags in, but we never had much success with that. Maybe 1 or 2 fish this summer, so we got this batch 20 fish out of Priest Lake, and that was why we released them at, white-tailed butte and at thick and sheet. Because we suspected if these fish could not get through the dam, they would likely seek out cold water, and that is what they in large part did when the Riverville Outlet Dam got above 20C. Yes.
When you say you caught these fish on Kavanaugh Bay, were you along the road next to the lake, or were you actually hitting from Kavanaugh?
Oh, so the question was, do we catch these fish along Kavanaugh Bay, along the lake, along the road? So essentially on that east side of Priest Lake, there's a number of pull-offs on that road. So you got that big rocky point at the north end of Kavanaugh Bay. So
I live there.
Okay.
So you weren't in where the cabins are, you were beyond, you were north
Yes.
of those.
Yes, we were on that shore, just a little north of Rocky Point and south of Hunt Creek. So that's stretch of shore.
I think he wants your
That
fishing
should be the
spot.
spot.
Okay, yeah.
I have,
Yes.
so, if I'm thinking this out right, if there's not fish, you're not seeing them that are using the tributaries above East Fork, right? Would historically, if there was a summer connection, for them to migrate, could they have been migrating in those further up tributaries and then be rearing in Priest Lake itself? Would the timing, are they shut down access? Are they like done spawning when they would be, and like, is the movement between the dam, like when they're done spawning on the tributaries, are they already blocked by the dam to move up? Because it seems like there would have been a historic population that was like using tributaries and then moving back up to the lake. I don't know, I don't have any proof of this, but that seems rational.
Yeah, so the question.
Is the timing.
Yeah, so the question was, the timing of cutthroat trout spawning, when they're done spawning specifically, is out of the dam being operated for summer lake level. So based off of the work that Joe has been doing, these adult cutthroats are usually exiting the streams in early May. It seems like the month of June is when outlet dam really starts being operated. So I would say if there are fish that is the timing, they can, as long as they get past that dam before June, they can move through. Speaking of historical context, I've always thought of fish as explorers. I mean, they're always going to move around all over where they can swim. So I think this might be that, greater Monterey Basin fish is travel. Anybody else?
Could there have been a break someplace in Priest River prior to the dam where resident fish in the lake could migrate downstream, maybe spawn in a tributary or something and tend to go up, whereas what we're seeing or hearing previously, where some of those fish are programmed to go back to Lake Monterey? Could there have been a dividing point that those fish would migrate back to?
Okay, so the question, as I understand it, is there a dividing point in these streams in the Priest River that determine if fish are going down into Lake Monterey and grow big compared to staying in the stream as resident fish?
Or prior to the dam.
Prior to the dam.
Yeah, prior to the dam, migrating up to Priest Lake.
Oh. Well, I do not know the historical geology of this, but I could speak to what Rob said about resident fish versus migratory fish. It seems like having a resident life history or migratory life history is a way that these fish can hack it in a volatile environment. So there could be, streams do change course over time. There can be landslides, there can be a new waterfall emerging, that sort of thing. If a fish is no longer able to basically get down to the bigger water to grow, they can keep reproducing in the stream. So I guess a really good example of something like this is if you go over to Lake Roosevelt, where you have Grand Coulee Dam in place, steelhead can no longer, rainbow trout can leave Lake Roosevelt, go down to the ocean, but they cannot get past Grand Coulee Dam. But there are rainbow trout that spawn in tributaries of the lake, and if given the opportunity to get back, that life history can be restored. So some fish have a tendency to always move out, and then when the time comes, they can get back into what they were doing historically. So I guess having that resident life history or that migratory life history in the same stream is a way for fish to wait out, maybe a geological barrier or some sort of stream that changes the environment.
I guess another way to ask the question is, could there have been a higher population of cutthroat trout in Priest River, but then they would migrate both directions to find a lake that was.
Oh, okay. Question was there a migratory population of cutthroat in the Priest River that goes both ways to Lake Monterey and Priest Lake?
Or choose or would historically migrate either north to Priest Lake or southeast to Monterey?
Well, I think that's certainly a possibility. Robbie,
I think that's one interpretation, and it's sort of in part why I inserted that quote from Ted Dior in this report, that there was some speculation that oral history suggests fishing was better in that portion of the river just below lake,
in the spawning period, suggesting maybe fish flying bait back and forth for some spawning activity. That was then maybe altered in some way by the dam. Obviously, that report was not too long after the dam was constructed, but perhaps that was a potential issue. And I don't know. I know that there are some other issues in tributaries that may have been spawning tributaries of the river that are closer to Priest Lake, for example, but Orange Creek has a culvert under the highway that sounds like is probably a migration barrier now. In history, there wouldn't have been a migration barrier there, and that may have contributed to more spawning activity further up in the river as well. So that's another potential. I think it's something you got to kind of theorize on. I don't know that we have answers of the work that Brian and others have done.
Do you guys got any questions for Joe, Rob, myself, amongst all presentations? Yes.
I got one for all the biologists and hydrologists that spend time on the river. We're hearing a lot about, something Joe said kind of resonated with me that, without cold water temperatures, that's kind of the bottleneck for productivity, or it appears to be. Do you think there are other opportunities to improve other habitat components in the river? And would it make sense to concentrate on those if we're not getting colder water temperatures in the river?
So the question was, is there opportunity for improving habitat in the Priest River? And I think there could be. I'm just basing this off of the radiostelemetry work we did, where these fish were stacking up at the mouths of springs, and there's no overhead cover. Eric Burtson here, he is our hydrologist. He implements restoration projects. I can see there being potential for some sort of large wave debris stuff in those sort of spring pockets. Because currently, as it stands, some of those pockets are just a sandy bottom. We're going to go year round.
I think, in my opinion, I guess, there's a sort of a trump card that temperature plays relative to all the other habitat characteristics. So you can improve habitat to address quantities of fish, likely, but if you still have warm water temperature that limits them through a significant portion of the year, they can't occupy that habitat that you've made better. Now, there was some work, and both of you highlighted some of the cold water pockets within the river that exist now that reference either groundwater inputs or tributary inputs that provide some little holes of cold water. Those provide some small space, but again, you can't fit so many fish in there, and then they have to occupy some of that broader river. And if they can't live there throughout a long period of the season, then you lose out on that space collectively, so you limit the population. There's a trump card there. You can do everything you want, you're still going to come up against this issue with hot water that limits fish.
Yes.
One of the other things that comes to mind when you talk about these streams as cold water refuge, like this year, there's a lot of those streams are probably going to go dry because the snowpack is gone.
Right.
We never did get normal snowpack in the Selkirks this year. So is that going to basically negate any of these efforts that you might do in some of these refugia? Because refugia will only be here 1 year out of 5 or 1 year out of 3.
Yes, so the question was, will this potential work to improve cold water refugia, will it be meaningful in drought years when there is?
We're going to have 2 in the last 3.
Yes.
The last 3 years are going to be drought years.
Mm-hmm. Is it meaningful?
Well, I mean, I could say that any effort we make towards creating cold water habitat for these fish is important, no matter how small that effort might be. Even if it doesn't make as large of a difference in the long run, any chance we can give these fish to find cold water to survive these long summers is very important. However, I can't say it's going to be a long-term fix. We look at a lot of these, we can improve as many culverts as we want, we can increase as many freshwater springs as we want to enlarge these freshwater refuge sites.
But long-term, these sites, as the drought continues, are going to shrink themselves, and it's not a long-term fix. It's important, you can buy some time, but I don't see it being the answer for the long-term. My opinion.
You got any questions for people in TV land?
We don't.
Okay. Do you have questions?
Well, what do you see?
Science. Meaningful. I certainly agree. Any effort that we do to help out fish is worth our.
I don't know, like, it's kind of a general question, but I just am like interested in how brook trout plays into this and, like if that's factored in or if they actually, I just don't know a ton about them specifically, but like, are these temperatures allowing them to or have more success like in with cutthroat or because you had said, Rob, like if habitat's really good, the cutthroat kind of can hang on. And so that made me think like as it degrades, not just temperature, but habitat value in general towards more of like a silty or what different conditions like cutthroat then start to lose their battle. Is that accurate or is that a correct interpretation of what you're saying?
I'm not sure I would say it exactly the same way, but
Okay.
So in general, brook trout are competitive with other native fish. Cutthroat trout commonly are the ones where we were thinking about them. Bull trout would be another example for a combination of reasons in that case because of hybridization. But
yeah.
In general, brook trout tend to outcompete cutthroat when they're placed in the same environment.
Yeah.
I would say that when habitat conditions are good, that cutthroat win out or
okay.
When habitat conditions are less desirable, that brook trout tend to be even more competitive. So you would generally see what we tend to see when we do broad surveys like we're working on now, like we did on tributaries to Priest Lake, is that those lower reaches of tributaries that might generally be a little warmer, often they're lower gradient, they maybe don't have the same substrate, they're more sediment laden because they're in these lower reaches that have a combination of challenges, perhaps. Those tend to be the places that brook trout tend to win out first.
Mm-hmm.
Broadly, in the case of, I guess, the Priest River tributaries, what we saw in terms of the trend over time is that brook trout are present in a number of tributaries. They are more on cutthroat in some places, but overall, it hasn't been an ongoing spread over time. That is something people worry about in some places, but it hasn't occurred necessarily there as a trend over time. And that might in part be because there is a lot of good quality habitat. In the lower section, the Priest River tributaries, below the lake, so far what we've seen are there are a number of sections of streams that are dominated by brook trout in some areas and other areas not, and it tends to be kind of a similar case where those are maybe the lower gradient, especially the lower reaches of those lower gradient streams where they're slow meandering streams that are warmer in temperature. Again, habitat quality may not be quite as good, so brook trout can kind of take advantage.
Yeah.
They're more tolerant to disturbed areas or just areas in general that may not be disturbed, but they have warmer water temperatures because of their location with the drainage. So,
do we know, like, are their populations increasing? I guess fundamentally we get it as cutthroats are decreasing, it seems like, in some way.
First of all, I guess the tributary habitats, what we're trying to describe in part of the survey we're doing is how those populations may have changed over time. So I wouldn't say necessarily that in the near term, I would expect or not expect that cutthroat trout populations have dramatically declined in the tributaries of the Priest River. They may have, but that's kind of what we're trying to understand. And I guess I don't know for the same reason. I wouldn't know exactly if brook trout populations in the near term again have expanded dramatically or not. They definitely have since the bigger stock. Most of that stocking was done pre-1970s, so they've been there a while. They've had some time to do things they've done. Certainly across the range where they've been distributed by people, or they've been introduced as an on-export fish, there are examples, there are quite a few of them, where brook trout have outcompeted the native fish and replaced them. So it's something that people worry about in today's day and age, having learned that lesson and trying to manage the fish populations.
Okay.
Does that help?
Yeah, it helps. It helps. So they spawn like 12 other questions.
May I add just one comment to the brook trout? Having electrofished a lot in a lot of the tributaries of Priest, Kootenai, Ponderay, it's not scientifically rigorous, but it would seem we see less brook trout doing well above 13% stream slope. So it seems like cutthroat do better in steeper gradients.
Yeah.
That goes to the gradient comment.
Yeah.
I've done that research too.
I have a couple questions. So brook trout are a big problem. First question, is there any suppression efforts by Fish and Game to try to reduce their population? And then also I would comment on Priest Lake, because there wasn't a lot of discussion about fish populations in Priest Lake. Lake trout are pretty prevalent in Priest Lake. And that, I think, it seems to me, and also we have the that are planning conditions, but at least in my experience, the cutthroats seem to be declining and they're going rapidly over the last decade or so. And all of that's attributed to lake trout and so on, but at least that's what I hear. But if that's the case, then again, I guess we'll go back again to the significance. So if the lake trout is, if the cutthroats are declining in the lake, it seems like the connectivity problem is really kind of not like significant.
The connectivity is down. So I think the first one. So
brook trout suppression.
Brook trout suppression. Yeah. So in the Priest River drainage, there has been some work, very minimal amount of work to suppress brook trout. One project in particular that I'm aware of is located in Keel Creek, which is a tributary to the Northeast River. That work was done specifically to benefit bull trout, and there was an isolated section of stream that seemed potentially easy to remove brook trout and quantity enough to limit their impact to the Northeast River. I think some of our work that's ongoing right now with inventory may help us think about opportunities to actually do some of these projects. We are looking for those types of opportunities. They're challenging though, because you've got a mix of fish species, and the tool to remove brook trout is often a chemical removal. So when you do that, it's not just a brook trout removal, it's a fish removal, and you have to either prepare for that by first removing fish that are desirable, or have a backup plan to replace them once you have removed those. So an example that I've been thinking about that comes from the results of our inventory work, this is Bernard Street that I mentioned earlier, and the barrier brook trout are actually fairly prevalent from the barrier upstream some distance in cutthroat arm. There's an additional barrier above that where it's the only cutthroat. This is something that you often see when there are natural barriers in streams or unnatural barriers that prevent fish movement. Their impacts may be limited to one section. And that actually is a benefit in the sense that it provides sort of this isolated area where you can kind of wrap your head around treating the problem and then reintroducing what you'd like to see there. So I think we will be looking for additional opportunities for that type of work across the state. We're doing that pretty broadly. In fact, there's some ongoing work with some unique things using called genetically modified fish. It's not exactly the right case, but super brook trout, super male brook trout that are actually used to introduce and sort of reduce brook trout abundance by creating an all male population, essentially, by stocking some fish that have been changed in a way that when they spawn with wild fish, they create all males in the abundance. It's kind of some up and coming things that is being done in Idaho that's also being adapted across the West. These guys are involved in some of that work in Washington. And, after I'm done, let them talk about brook trout removals because they're very actively doing some of that work on the Washington side to benefit cutthroat and potentially bull trout down the road there. That's kind of stage one. The second half of the question was about Priest Lake.
Excuse me, we've got a meeting at 7 o'clock here now, but we're gonna give you that hour to continue on, so don't worry about it.
Well, and it's not really their fault because they have us down for the 15th, not the second.
So-
Yeah.
You're good.
Okay. Sorry for interrupting. Yeah.
So the second part of the question is about, if cutthroat were in decline in Priest Lake because of lake trout and we're managing for lake trout there, would passage at the dam be an issue? And I think that's probably a fair point. I guess I take a little different perspective on the abundance and the trend of cutthroat in Priest Lake, Upper Priest Lake currently. So we have been doing some monitoring work specifically targeting cutthroat trout and Priest Lake and Upper Priest Lake since 2014. We had a series of 3 surveys so far, so that doesn't cover a huge, we're coming up on a decade, I guess, but in that work, what we've seen is that populations in both lakes are relatively stable. Catch rates suggest that they're actually moderate abundance of cutthroat in both lakes. There is slightly higher abundance represented by these catch rates in our survey in Upper Priest Lake, which would suggest that our work on Upper Priest Lake, which is a whole other story, but it's managing for native fish there by reducing lake trout abundance. That's something that's gone on there for 20 plus years or so, but that work has had a benefit for native fish. I think that's a fair conclusion because of the higher abundance.
I guess that's my point really is, this is a really complex issue.
Sure.
In terms of trout population, bull trout population, it's very complicated.
It is complex, and I think it's fair to think about all those things.
We should wrap it up because, yeah, we can take, let's say 2 more questions. And I see Bill and Jeremy, right?
A brief comment. My name is Bill Love. I'm the president of the Panhandle Chapter of Trout Unlimited. And speaking on behalf of the rank and file members of Trout Unlimited, those that pay their $35 a year annual dues, we certainly want to acknowledge the work that Aaron Plume has been doing as a TU staff member on behalf of the Priest River Watershed Group. And also would like to acknowledge Amy Anderson, who's our chapter's bull trout education person and works with us and along with the Vista and Fishing Game and others in promoting educational materials about protecting bull trout. So thank you, Aaron and Amy.
Yeah.
Last question?
Just a question for all of you guys. Temperature is the biggest issue on the Priest River for our native trout species. And from the numbers we're looking at, it looks like numbers have dropped quite a bit. Do we see it? Does it make sense to keep leaning into the native species and other trout species thrive better in a warmer temperature, like the brown trout, brook trout, etc.?
Okay, so your question is regarding water temperature and fish species composition. So it makes sense to focus with fish that are less tolerant of warm water than say fish that are warm tolerant. So you have cutthroat trout got lower temperature tolerance, say brown trout with warmer water. To me personally, it comes down to native species, the fish that have always been here. If we cannot help what's always been here remain here, that says a lot about us. So I think we should do what we can about the native fish. Joe?
I'd have to agree with what Brian said, and that I'm a big person. I love fishing for native species. I like seeing cutthroat. I like seeing bull trout.
There's something about these fish that survive in these cool water creeks. I can't imagine the only one that heads way up into the Selkirks, and I'm just tickled to be able to catch these even small cutthroat in these headwater streams. And I certainly think we'd be losing something if we lost these guys. To be able to hike up into some of these alpine lakes or even some of these headwater drainages, and we'd be missing a part of that. And I know that's a big motivator for me that got me involved in this work, is to be able to try to conserve these populations so that later on down the line, when we're telling our grandkids and our future generations, well, what about those cutthroat? What were they like? Instead of having to describe what they were or show a picture, we can actually just go out and say, here's how you cutthroat. This is where they are, and this is how they do it. So, I mean, that's one of my big motivators in what we do. So, from a personal perspective, that's, I guess, my take on it. I do love fishing for lake trout and another species though too. They're a lot of fun. All fish are cool, as Brian says. Big or small, cherish them all. So.
I think I'll just highlight the snorkel survey data from the Priest River that I shared with you. So we're talking about the Priest River in general. That suggests to me that most fish species were limited in some way, and it's likely not a real habitable place when water temperatures are real high. And we can see that especially in periods where we do get these extreme events and we do get fairly large fish kills. So fish that are marginally tolerant to some additional heat, you might classify whitefish like that. Perhaps brown. I think we give brown trout a little more credit for their temperature tolerance than they really do. They're probably not that much more suitable. If you looked at what we saw in the river, in general, those fish were still limited, even though they're present. So there's a limitation there that's broader that I think stocking something new can fix. The other side of that is we do have some fish that are more generally classified as, again, cool water, I guess, but smallmouth bass in particular. So even though that they are present, they may do well in warmer water temperatures, they're still not, the combination of things there isn't right. So we don't have this strong warm water fishery component, even though we've got warm water fish. So again, we can't rely on that as an alternative to make fishing better applications. If it's purely about making fishing better, it's a really tough place to do that. It's complex.
Thank you.
Can I say something real quick?
There's more hands popping up.
So this is an indirect response to the question. Like, for those of you who don't know, I'm a fish manager. I just wanted to kind of highlight what I think is an important take-home message for the stuff these guys shared tonight, which is that, I mean, the Priest River is currently offering a fair bit, right? And we learned that about a third of the cutthroat population in Lake Monterey is coming from tributaries to the Priest River, for example. So there's a lot that is already on the ground out there that's being offered by the Priest River. But I think we also see that the fish that are out there right now are doing as well as they are because they are well adapted to dealing with what's a pretty difficult environment to live in the summertime in the basin. So you have these migratory fish that seasonally move in. They use these small tributaries for spawning and rearing. So the Priest River is a nursery area really in a lot of cases because these small tributaries have a lot to offer for producing these juvenile cutthroat, these juvenile bull trout, depending on how they use the lake. But those adult fish have to move out of the system or occupy these real small areas, the cold water to get that. So if temperatures were cooler, we would anticipate being able to have a higher number of these fish, or potentially different life histories. You heard these guys talk about these fish wouldn't have to necessarily be as migratory, moving out, going to the lake in the summertime. We expect more fish to be what we call fluvial. Those are fish that would maybe spawn in these tributaries, then they would just occupy the main stem Priest River in the summertime if it was cold enough. So that's what's missing in the Priest River right now that we see in a lot of our other rivers, like the Portland River and St. Joe River, some of those places that are colder main stem habitat. So anyway, I just wanted to really highlight that. I think these guys provide a lot of really good information about that. But I think, yeah, that's the take home. The cool thing is we have a lot of the parts and pieces there for these native fish. They're already doing pretty well in these tributaries. It's just, there's some real challenges there for fish to occupy the main stem through the summer.
Okay, Sean Stash had one more question. Oh,
So what do you base the assumption on that if the
main stem was cooler, they would stay there rather than migrate to go up to that.
Yeah, I think I kind of guessed, I think maybe it was one of you guys made that comment earlier. A lot of these fish have these diverse life histories, and it allows them to, depending on circumstances or environmental events, to be somewhat plastic, take advantage of different environments or respond if you do have, I think you referenced a landslide or something like that might cut off habitat. But we do definitely see that where fish can transition a little bit in how they what life history they exhibit.
Do you want to ask a quick question?
Yeah. So it's concerning when Joe was talking about what their trap data was showing in the primary spawning tributaries in the lower Priest River, to see these declines in fish, especially from the main stronghold tributaries of the stream. I can't remember from the graph you showed, was that a decline in juvenile fish or a decline in adults or a decline in both?
That's a decline in juvenile fish. The adult trend is slightly more stable, but it's still in a downward direction.
So would that maybe lead us to be a little concerned about spawning success in these tributaries, and should we be looking at what could be causing this decline?
I think that's certainly worthy of more research. I almost think we're already seeing some of those effects now. We look at our, like I mentioned before, returns this year, the lowest they ever have been. These juveniles tend to rear for 2 years in the tributaries. 2 years ago, we had the record-breaking temperatures ever seen in this area. So, as far as more research to keep these trips cold and keep them good habitat for a lot of these fish, I'm all ears. Mine sits on it a lot. There's a lot of work to be done.
And now, I think you said that you guys were thinking about pulling your traps.
Possibly in these next couple of years. We've been considering stopping the trapping altogether. That's something I've been considering. Just looking at the fact that how long these traps have been in place, and the fact that we do leave a gap for fish to move up past these traps, but just the presence of them impedes these cutthroats migration. Even if it's only 1 in 10 that turns tail and goes back, that's still another spawner that we don't have in that creek. So, it's worthy gathering this data to people. One good comment I had from one of our other biologists was, I was really struggling this year because it's like, we're not catching fish, and I was getting really worried, but he made the important points. We're doing all we can, but they're just not here. And it's almost as important to document their absence as it is for their presence.
It would be a little unfortunate, in a sense, if you did remove the traps, because then nobody's keeping track of whether or not the juveniles are rebounding or are they continuing to plummet. And then I feel like it could just be overlooked, because nobody knows what's going on and we've moved on to other things. And so, anyway, there's pros and cons against keeping track.
Things like retirements and things like that.
Thanks for that opportunity.
Thanks everybody for coming out tonight. We can all agree that we hear about the Priest River in this drainage. So.
Thank you.
Well, I just want to say we do have another meeting next week. This one's Forest Service and IDL talking about kind of their roles in this watershed. And also Fish and Wildlife Service wasn't able to make it to this meeting, and so they'll be joining that meeting, talking about bull trout a little bit. That's probably mostly about ESA protections and endangered species protection and what that means more than like fish data and that information. But yeah, so hopefully we'll see you again then.
Do you need help with this chair clearing?
Sure. I'll take all the
Good job considering. I'll be,
unless you're afraid of this
Yeah.
So even though the pre-storage gets to something like 70 degrees, summertime, a while, the whole time it could survive. So if it gets too warm or too hot, it's either going to bug out or it's going to shut the time. But the summertime for a lot of these cold weather, and then getting into the pre-storage, it's actually a time where they don't grow. So it's a time where they're kind of like fixing their activity.
The electric storm has been shit hit the fan. It's the variable. You guys like it?
Growth is the best for the reference. But then if you look at like the natural minutes,
Do you want to watch the breakdown? Yeah. Okay. So let's see. So we have, so right now, well, today we're here at I came early to come back.
I would say
So I thought I was but yeah, we were just talking about it's not well, the last one, it was like this is also Turkish. No, don't be. It's okay. We'll write it down. She want to talk about it. But we had so that's not. But no, it's not. I mean, it slows everything down. It slows the advancing down. All of it is. But if you didn't, yeah, because it has to. By sending it out to the world. Yeah. But no matter what, if you don't have Zoom, whether you, yeah, thanks. Good to see you. So this is HDMI from their TV, and if you don't have Zoom, you can simply just plug this in. You can have a power.
Oh, it's over there.
I've never used. Okay, and so that, yeah, that you need, Ryan, and me.
Bye-bye.
That you need so you can plug everything in. So this is the mouse. That's the adapter.
I haven't, so I've been like all over the place.
That's the strategy.
Would we have to have some kind of enhancement program to get more out in there?
So since it's a connection system, you can expect you to have my recommendation is that you want to